Hello everyone, hope you all are doing good. So before starting today's video, let me tell you that you will get all the solutions in the Telegram group. The link is given in the description and you will also find the link in the comment section. So do join it to get the solutions in C++ as well as in Java. So now let's start today's video. So today's GFG POTD is about count pairs in an array. So let's read the problem once. So given an array of n integers, we need to count all the pairs in it such that this condition applies. And here zero based indexing is followed. So let's jump into the solving part now. 0 1 2 3 4 5 6. So these are the indexes. Now we need to multiply this index with the elements of the array. So 5 into 0 is 0, 0 into 1 is 0 again, 10 into 2 is 20, 2 into 3 is 6, 4 into 4 is 16, 5 and 36. Now we need to see whether this condition applies or not. So we need to see what if my array of if an element is greater than the rest of the elements after that or not. So is 0 greater than the rest of the elements? Any elements? No. Is my this 0 greater than any other elements in this remaining array? No. Again, so is 20 greater than any elements remaining in this array? Yes, it is. So 20 and 6. 20 is greater than 6 and 20 is also greater than 16. So 20 comma 16. 20 is greater than 5 also. So 20 comma 5. Again, no more elements. So now moving to 6. Is 6 greater than 16? No, it is not. Is 6 greater than 5? Yes, it is. So count it. Is my 6 greater than 36? No. Is my 6 now moving to 16? Is my 16 greater than 5? Yes, it is greater than 5. So let's count. Is my 16 greater than 36? No. Moving to 5. Is my 5 greater than 36? No. Is now remaining is 36. So let's count this. So it will be 5. The count is 5. You can see the answer here. Okay, so what we will do, we will simply apply merge sort. We will simply sort and merge the array using merge sort. But before doing that, we will check if our element at array I, index I, is greater than element at array index j or not. If it is greater, then we will just increase this counter. Okay, so let's not waste our time. Let's start solving this problem. But before that, let's observe something. And this will be used later on, so do pay your attention. Now, these are two arrays. These two arrays are sorted. We need to check if the element of this array is greater than the element of these arrays or this array is or not. So is my 0 greater than 3? No, it is not. Is my 1 greater than 3? No, it is not. Is my 4 greater than 3? Yes, it is. Okay, these are not. Is my 8 greater than 3? Yes, it is. Is my 10 greater than 3? Yes, it is. So are you observing something? The elements after 4 are all greater than 3. That means in a sorted array, if one element is greater than 3, then all the elements that are present in the right side will also be greater than 3. Okay, so now let's move to our next element, that is 5. Is 0 greater than 5? No. Is 1 greater than 5? No. Is 4 greater than 5? No. Is my 8 greater than 5? Yes. Then what will happen? Then our 10 will also be greater than 5. Why? Because the if element 8 is greater than 5, then all the elements that are in the right side of 8 will also be greater than 8 in our sorted array, right? Similarly, this will also happen with this particular element. Now let's move to our this particular array. So we will operate on this particular array, right? So let me first take this array. 0 0 20 6 16 5 36. Okay, so now we need to apply merge sort. Now what is the midpoint? How to find the midpoint? Midpoint is our L plus R by 2. L plus R by 2. So what is L? It is 0. And R, what is R? 0 1 2 3 4 5 6. It is 6. So 6 by 2 3. So our midpoint will be this one. So let's divide now. Merge sort is all about divide and conquer. So we need to first divide this. So 0 0 20 6. Now let's divide this again. Now how we will split this? We will split this into 0, 0 and 26. This is an array, okay? 0, 0, 26. And again, it will be split into 0 and 0. And this will be 20 and 6. Now we need to check, before merging, we need to check what is my 0 greater than 0? No, it is not. So it will return as it is. Is my 20 great, and my counter is initialized to 0 now, okay? So is my 20 greater than 6? Yes, it is. So 6 will come here and my 20 will go here. But before that, what will happen? Our counter will increment to 1 because we have got our one element that is greater than 6. Now, moving here. Now we will compare what? We will compare 0, 0 and 620. Is my 0 greater than 6? No. Is my 0 greater than 6? No. Is my 0 greater than 20? No. Is my 0 greater than 20? No. So, just sort and merge. So, 0, 0, 6, 20. Now, we will split this right part. 16, 5, 36. Break this. 16 and 5, and this will be 36. Again, let's break this. 16, 5. Is my 16 greater than 5? Yes, it is greater than 5. So, our counter will increment to 1 again, and this will become 5, 16. Applying merge sort, right? And here we have 36. Now we will compare what? We will compare this and this array. So, 5, 16 and my 36 here. So is my 5 greater than 36? No, it is not. Is my 16 greater than 36? No, it is not. So just merge this. 5, 16 and 36. Now we will compare this array and this array. So what is this? It is 0, 0, 20 and 6. Oh, sorry, 0, 0, 6 and 20. And we have another array that is this 5, 16 and 36. So 5, 16, 36. Now let's compare this. Is my 0 greater than 5? No, it is not. Okay, move forward. 0 greater than 5? No, it is not. Move forward. Is my 6 greater than 5? Yes, it is. So now what will happen? The element 6 is greater than 5. What that means? It means that the elements that are in the right side, the elements that are remaining in the right side will also be greater than 5. So 6 and 20 both are greater than 5. So we need not have to count. We have to count. We did not have to move forward now. So our counter will increment to 2. Why? Because two elements here are greater than 5. Now moving to this 16. Is my 0 greater than 16? No. Is my 0 greater than 16? No. Is my 6 greater than 16? No. Is my 20 greater than 16? Yes, it is. So plus 1 and 36. Is my 0 greater than 36? No. Is my 0 greater than 36? No. Is my 6 greater than 36? No. Is my 20 greater than 36? No. So sum it up. What are we getting here? 1 plus 1 plus 2 plus 1. It is 5. So this is our answer. So we are getting our answer perfectly, right? And after that, just merge this, okay? This one, this array, and this array, okay? Now let's implement the code. So let's take a vector called a, and then we will do the operation. What operation? We will multiply the index with the element, right? And push it in our vector a. Now simply return this merge sort a comma 0 comma n minus 1. This is our low, this is our high. Now let's implement our merge sort function. Counter equals to 0. Now it's a base case. If my low is greater than high, then we will return our counter. Or else we will first need to find out the mid. How to find the mid? I've shown you. L plus R by 2. Oh, sorry, it is low plus high by 2. Now count. Do the sorting from low to mid for this particular array, and from mid to high will be for this part. Implement the merge function. We will pass all the three arguments, low, mid, and high. And at last, return our count. What we will do now? We will just merge. We will take a vector called temp. We will initialize our left to low, our our right to mid plus 1, and our counter will be initialized to 0. Just traversing the array, and we will do the possible comparisons here. So if my array element at in left is less than equals to, okay, I've taken here a right, so and increment our left, or else what our main condition, if this is greater than our element at index j, so we will increment our counter. Now why we are doing this? Okay, so let me tell you why we are doing this. Suppose for this we are counting two elements here, right? So our index here is, it is at 2 and it is at 3, so our mid will be 3 and our index is at 2 plus 1. What it is coming? 3 minus 2 is 1 plus 1, and our count will become 2. This is our count, right? So this is why we are counting like this. Now pushing the right part and incremented it. Now there is a possibility that one of our index will be exhausted, so we need to take care of that also. If the elements in the left side exhaust, then this loop will work. Or else, if the elements in the right side exhaust, then this loop will work. One of the array will exhaust, okay? So we need to implement this. Now what? Now we will put back into this. I minus low, and at last we will return our C. Now let's compile and run. Okay, a dot push. Again an error, push back. Okay, so the compilation completed. We are getting our correct output. Now let's submit. Okay, so the problem solved successfully. So let's end the video here, but before that, do subscribe the channel to get similar content, as gaining a subscriber and a like in my videos does motivates me a lot to be consistent and create more such content. So do subscribe, like, and share it with your friends. If you have any doubt, you can ask me in the comment section. Thanks a lot for watching. See you guys again tomorrow.